Wow. I feel like I have the power, just change the slide on the screen and people are like, oh, that's amazing. Hey guys, I'm so happy to see that not a lot of you actually left. It's amazing. That's a good sign. Thank you. Now we're going to talk about container support on Lambda. And hopefully this will be a bit more interactive one, but I hope you liked the previous one as well. So the last announcement we talked about was in 2018. 2 years after that, AWS announced, hey, now instead of actually having this 50 megabyte deployment package limitation, I'm gonna let you deploy your functions as container images, and those images can go up to 10 gigabytes in size. And of course, a lot of people got happy. I got really upset because containers was invented in 2013. It was really a long time ago. You could have done that before, let's be honest. But we're not here to complain about that. What we are here to talk about is the rules of the game. The same way that we spoke about interacting with the runtime API and having the bootstrap file is the rule of the game for the custom runtime. Let's see what's different for us when using containers. So the first one is you have your container or whatever's in there must deal with the runtime API. So we spoke about that earlier. And your image must be stored at the Amazon Elastic Container Registry, or ECR for short. So Docker Hub is not an option. There are a lot of reasons why that's the case, but not a lot of technical reasons why that's the case. Okay, they're really important to mention. So when you put it this way, it's like, oh, I have to implement the runtime API. Okay, it's not really hard for someone to start making the following question. So, okay, so this is like creating a custom runtime, but packaging that differently, right? Because it seems like it. It seems to be the exact same requirements. And honestly, the answer is not exactly. And by the way, whenever you see a question in anyone's presentation, the answer is no, 90% of the time, okay? So the reason why this is not exactly the case is a bit more complex than that. So I need you to make a mental note on two things I'm going to talk about now. So the name of the two processes, and because they are very similar, it's very easy for people to get confused, so hang in there. And the second thing is, there are more bullet points, so hang in there again. So the Amazon will provide base images that contain the runtime interface client, and client is the key word I need you to remember. So that's a binary that interacts with the runtime API, so you don't have to. Really important. So whenever you are dealing with containers, someone has integrated with the runtime API, and if the Lambda service evolves, you just need to download the latest version. That's one less word for you to worry about. Okay? And there is the runtime interface emulator. Remember when I complained about the /next endpoint from the custom runtime presentation, and I said, hey, there's such an abuse of the HTTP protocol because you make a request, but you don't get an answer unless you have something to process? Yes, the reason why they created the runtime interface emulator is that if you didn't have that otherwise, that request would fail straight away. So you need some program to lie to your runtime interface client saying, you know what, you're actually running on the Lambda service. So this is the whole purpose of the emulator, is to pretend that that was a good decision. So the runtime interface emulator provides this Lambda service-like environment. So if you remember, client is the runtime API, and emulator is the person who is compulsively a liar, to the runtime client. You're good. And another thing to say is the base images are provided for Python, Node.js, Java, .NET, Go, and Ruby. So yes, there are more languages that are supported out of the box. But again, how does all of these fit together? Because it's hard to actually understand, how each piece interact at each given point in time. And I would risk saying that the whole reason why we are here tonight is because if you read the AWS's documentation, you can't get that straight away. It will take you some time. So that's my mission to clarify that for you. And if you have probably a better idea after leaving this meeting, please create a pull request for them and tell that their documentation needs to be improved. So imagine that you are running a Lambda function locally, okay? So you as a user say, hey Docker, I need to run my container. Your container will trigger the bootstrap file, and this bootstrap file has to do a lot of things. So the first thing it needs to do is to initiate the runtime interface client, which is the one that interacts with the runtime API. Don't forget that. Your runtime interface client needs to know how to load your function code, whatever that is. It needs to know where this is and how we can actually run this, okay? But important thing, the runtime interface client is a separate binary, so we know when it comes to performance what that means. Also, the bootstrap will actually make this weird logic, but it's a very interesting one. It checks for the existence of a specific environment variable, and if that variable is present, it thinks, okay, I'm actually running on Lambda service, so runtime emulator, don't do anything, stay where you are. But if that variable is not, if that variable is not assigned, is not set, then what the bootstrap thinks is, I'm actually running locally. So, hey runtime interface emulator, I need you to lie to the runtime interface client, because when it tries to make a request, which is the get runtime/next, you will say, I got it, but in turn, you will actually expose a port to the external world, and this is the deal. Whenever someone sends a request to that port, you just get that payload and send it back to the runtime interface client. That's how all of those things fit together. When you run the exact same container in the cloud, because the environment variable is actually set, the runtime emulator doesn't need to do anything, so the runtime interface will actually talk to Lambda straight away, the Lambda service, their data plane or control plane. Does that make sense to you? Awesome, mission accomplished. I'm really happy. You have no idea how much. So, just to make sure I'm dotting all the I's and crossing all the T's, this is the way you would basically run things locally. So imagine that your container function is the my function column latest. So you run that exposing the port 9000 locally and mapping that to the port 8080 inside of the container. And then with that weird base URL, which could be much shorter, we all know that, with that weird URL, whatever you specify as the -d parameter will be sent as the payload. And then you are done. You're actually running things locally, and you can debug that with all the debugging tools you have available. You can profile your application. And this is priceless, because I know that people, romanticize debugging production. I'm so sorry, production is war. When things go wrong, we start the blaming game, and we need to find a solution. So what we do is to try to catch those bugs, early on. And this allows you to. So this is why I think this should be, much simpler for developers to know, because that's such a useful feature, okay? But I'm not gonna rant anymore, I promise. Who am I kidding? Of course I'm gonna rant about things. So because we built the bash runtime, I thought it would be a good idea to use the exact same one, so you would see the difference. So in this particular case, the only difference is that I'm actually using the base image, which contains, as you know, the runtime interface client and emulator, and this is the image I actually used. And the question, which I believe is is out there in the air, is how do I deploy that? But there is one more. I actually thought about the wrong slide. So the way you deploy is you have to specify an additional parameter, which is package type. And as code, instead of actually saying, this is the binary, you just say, this is the image URI, which should be pointing to your container registry. So no big deal. I think that one is really simple. So the question is, how does the packaging affect performance? Okay, and I don't think you will remember the numbers I said before, but there are a couple of things that need to be unpacked here. So the first three on the left are the images using the container image provided by AWS out of the box. I'm not doing anything different. And the other three are slightly different. So the fourth one and the fifth one are which is Bash and C respectively. They are using the container image provided by Amazon. So I'm not doing anything different. I'm just saying, hey, whatever you have, I'm using. And then the last one, I decided to go one step further and say, you know what? I do not want your container image. I'm going to create one from scratch myself and see if I can, make things run faster using the exact same strategy that we used before. So when you put those two together, what you will see is that the runtime, the cold start actually got slower for every single case. The source code is exactly the same. The only thing that I changed was the packaging mechanism. So why is that slower? That's a question that we probably need to know. We need to dig deeper into that. Not too deeper, but we need to know that a bit more, because if you are dealing with a specific use cases where you need all drops, single drop of performance, then that might be something you need to take into consideration, right? So that begs for the question: how does containers store files? Is actually grammatically wrong. Okay. Anyway, so take that for example. So I have this very, very basic container image, but it does something more interesting than you think. So I'm actually loading that from one container called Alpine, and then on the line number 3, I'm creating one layer which creates a folder and creates a file called test1, which contains the content hello world. And on the line 6, I'm creating yet another layer which deletes that file. And here's the interesting thing: when you map that, it actually looks like upside down. Let's see. Wrong animation. Okay, but the point is, the file test1 still exists, but exists at the middle layer. And then I deleted that file. So is the file deleted for real, or do we have some sort of abstraction layer that's kind of a line to us? And this is really interesting because there's a lot that we can infer out of that to justify why these things are actually slower. So, but before I go into that, when you're running containers, usually you have a read and write ephemeral layer, which means that whatever you do that, as soon as you leave the container or you stop the container, all of those changes are over. So now we have to go for the demo. Oh gosh. What do I want to demonstrate here? I really put a lot of thought in that. So I could really mutilate your self-esteem and show all the JSON files that Docker daemon actually uses. No one would actually like that. Not even me, because I will probably get lost. But what I can do is to show you how the Docker daemon actually puts together all of those layers, and then we can actually inspect that from a point of view that you wouldn't be able to if you were running Docker containers. So in that way, we can probably come to the conclusion why that's lower, and maybe even suggest how we can make it faster. All right? So be nice to me. Don't jinx it too much. Probably need to increase my screen. Can everyone read it, or should I increase it even more? Okay, that's good. All right. So I'm connected to my Linux VM, and then I have these custom runtimes here. The Docker file that I have is the one I showed you. So we have the Alpine, which is the base image, which contains like a lot of binaries and everything. I have a layer that creates this file called test1, and I have a layer that basically deletes that file. So first things first, I need to create 3 different folders to represent the different layers that my Docker container had. So I'm going to create the Alpine layer, the lower layer, and the upper layer. Okay? I do not need to bring all the binaries because it really doesn't make any sense. So what I'm going to do is I'm going to create a file inside of the Alpine layer saying Alpine image layer.txt. It really doesn't matter what's in that. As long as we see that, we know it comes from the Alpine layer, okay? The other thing I need to do in order to replicate that particular container image is I have to create a folder called test on both, both layers, the lower layer and the upper layer. In one of them, I have to create a file which contains something, and the other one, I need to find a way to say this file does not exist anymore. So what I will do is to make this folder called test, which existed on both of them, in both lower and upper layer, okay? And what I'm gonna do is to create the hello world file that will go to the middle layer or the lower layer. I should probably have called that middle layer. Sorry. Live demo. Awesome. Now, how do I tell the one layer that this file does not exist anymore? And this is very specifically tied up to which file system you're running. I do not want you to waste time with that. I do not want to bore you, okay? So just take my word for that one, and if you're interested in that, I can definitely tell you why that's the case. So if I create a character device, which sounds like a workaround, but if I create a character device, okay, which is gonna live on the upper layer, and we'll have the exact same name, and I say this is a character device, and the major version and the minor version exactly equals to 0. And if you think that this is workaround that doesn't make any sense, that's because it does not. This is the only thing that developers could agree on, that this does not make sense. But somehow we use that. Okay? So this is a file, but it's not a text file. It's just a file. Okay? Now, remember I told you that in the Docker container, you can have a read and write layer, which is ephemeral, and when you leave, changes are not going to be there. We need that one as well. So we're going to call it work, which is the work directory. Okay, easy. Now we need to mount that. So in order to mount that somewhere, we need to have it living somewhere, all right? So I'm going to call it mount point. And this is all the files we're going to create. I promise you, you don't have to keep track of anything anymore. But I have to specify the order of those layers that should be mounted on top of each other. And I need to know, how do I do that? And this is the thing that I've always struggled with our field. We complain about documentation not being up to date, but we don't like writing documentation. It's kind of weird for me. It's like a conundrum. So how do I get the latest information? And I'm going to show you this. So if I go here, oops, Linux, file system, overlay, entry, not that one, VL, entry, line 8. Don't ask me how I remember the line number. I have a weird memory. You will find this particular structure here. So that's the C code for the Linux kernel, okay? So the only things I want you to remember is these 3 parameters here. Lower dir, upper dir, work dir. Now we know exactly what we can specify. Okay, that's good. Second thing is, I need to know which format they have. Is it a string? Is it a text? How is it formatted, all right? And the way you can do that is looking at this file, and again, don't ask me how I remember this line, is looking at this particular piece of code. So lower dir upper dir, work dir, they are all string parameters. It's like, oh, nice, I have everything I need to. So I'll go back to where we were. So these are all the folders I have created. But one question before I do that. Has anyone in your company ever complained about the fact that Docker needs to run as root? No? Lucky ducks. Exactly, it's a security issue. If you ever find a security issue in Docker, that's a problem because it can escalate the privilege and then it can run as root. That's horrible. Of course, most recently you have an option to run Docker as a non-root user, which is a weird thing, but it still works. Don't get me wrong, but it will be even slower. Okay, but one of the biggest reasons why Docker needs to run as root is because of what we are going to do right now. I need to mount my file system. I cannot mount file system as a regular user. I need to have bigger privileges, and I can only do that as root. That's why. So now that we are here, we're going to do what I told you I would do. So I'm going to mount an overlay. And then I'm going to specify the parameters, which are the ones we saw a couple of files ago. That's the first time I've ever said a couple of files ago. Interesting. Interesting usage. So lower dir, and then I'm going to say that the first dir, which is the layer at the bottom, is going to be Alpine. Okay? I'm going to use semicolon. Not semicolon, column to actually separate the different lower dirs. And the second one will be the lower dir. Again, I should have chosen a different name, but too late for that. My upper dir will be the upper dir that we just saw. And the worker dir, no points for guessing, will be that one. Okay? Does that command make sense to you? Given what we just talked about? Okay. Aha. What did I miss? Can I find... Is overlay FS? Give me 1 second. I actually had something here. Just in case things went south as they did. You guys jinxed it really well. Congrats. So overlay lower dir. Yep, of course, that makes perfect sense. I forgot to tell my computer where to mount all of that. And we created the mount point. So this is where I wanted to mount. Aha! And now I need to actually switch it back to what I initially thought it was. Voila! After 5 attempts, it finally worked. Hopefully you guys still think I actually know what I'm talking about. So if I go to the mount point here, this is the interesting thing. I can see the Alpine image layer. I can see the test folder. So let's make sure that this is the folder. So as you can see, there is a D here. That stands for directory. And if I go inside of that folder, should I see or should I not see the test1 file? You guys are right. I can't see it. But does the file exist? And this is an interesting thing. If I go to the lower dir and say, hey, tell me what's the content of the lower test1, I can see it here. So why did I put together this demo? It's to basically justify to you why that thing should be slower. So a couple of things for you to keep in mind. So the file system that we're talking about, which is the overlay, is like wearing a pair of glasses. So you have a pair of lenses and you are looking at something through that angle, through those lenses, okay? But you are lying it. And you have to keep track of all of those files, because otherwise, how would you know that the test file has been deleted? But by the time you actually come to the conclusion that that file does not exist anymore, that took time. So of course, containers cannot be as fast as not having them. You're adding an additional layer. It can't be faster than not having it. That would be illogical. And no, I'm not quoting Spock from Star Trek. I just realized that. But that wouldn't make any sense. The second thing is, I created those files in a file system, and then I used yet a different file system to actually present that to the user in a different way. So we're dealing with two indirection layers of file system. That justifies why the cold start in containers are slow. And this is just the tip of the iceberg. There's so many other things, but we don't have the time to talk about the other nuances that the overlay FS actually has. And that's the preferred file system that Docker uses. And most likely, we cannot say for sure, but most likely Amazon is using some sort of Union FS, which is the category for these types of file system. So moving back to our presentation, the takeaways here is that containers provided by AWS do make things easier for most applications, and for most of you, having 100 milliseconds of cold start is not a big deal at all, and you should probably take advantage of that. If you're expecting to get every drop of performance, then those base images can be considered as bloated, because you have multiple processes, and we now know that it takes a little bit of time for launching multiple processes within the same container. And overlay FS or any UniFS file system has some negligible performance impact for most applications. So my mission here is not just say go for the best performance you can actually get. No, this is fun. This is what you should do on your spare time. But this should be just a card up your sleeve. That's what I'm saying. And hopefully you guys learned a thing or two, and I really appreciate it, the fact that you're all here. So I'm gonna open for some Q&A session. Yay! Does anyone have any question? Yes.
What would be like